Hello guys and welcome. This is day 5 of Days of 1,000 Subs, and it's going to be the last one because if I keep this going by day 9, it'll just be a live stream of me sleeping. Now, I don't know if you noticed, but this Friday was TooTallToby's World Championship Finals for CAD speed modeling, and I thought it was one of the best finals ever, and I thought it had some of the most interesting models ever, and I want to show you two of these models. So we're going to be doing two TooTallToby models today, but they're going to be World Championship level. So the first one is this one, and we have various materials with various density. It's a picnic table. You have some steel tubing underneath, and then you have ABS plastic for the tabletop and the benches. The tubing is a 50 by 30, so 50 outer, 30 inner, and 10 millimeter worth thickness from steel, right? And these are the drawings. Now, the really interesting part about this one is that you need to make cutouts for the tubes in the tabletop and the benches. And it's we'll be doing that in an assembly, so that's really interesting, right? Okay, so let's see how we're going to do that. Now, as usual, you have the way this is dimensioned is very typical of how you would find it in a manufacturing drawing, but there are some pitfalls. For example, this 685 dimension here is outer to outer, so in terms of center line path, that is also 685, but this 450 is, well, from the left side to the right side of the tube. So this 450 in terms of center line for a 50 millimeter diameter tube, this is actually 500 millimeters for the center line here. And you need to be looking very closely to the dimensions and doing that math in your head. So I will just put this here on the side, and we're going to start a new assembly, and I'm going to call this the picnic table. Well, I'm going to call this the TooTallToby World Championship picnic table, right? And we're going to start making parts. So I'm not going to be inserting any parts, of course. I will be making them. So these are the benches. By the way, in a speed modeling setting, I wouldn't be naming everything. Okay, so I tend to want to be putting solid. So that's my style, at least when I'm competing. You can check by my successes in TooTallToby's competition that might not be the best way to do it. But, you know, my style is let's start putting solids in there. So I would start in the XY plane, and I'd put a couple of rectangles for the benches. And I want to be making these equal there and there. Sorry, there. These are equal. This is vertical, and then this is midpoint with 3 points, so that, you know, okay, then I want a midpoint here as well. Now, dimensions. So this is 1700. Okay. And this is 200. And what's the outer one? Well, the outer one is on the bottom in the center of the sheet. In that view, it says that outer to outer, that's 1400. And it also tells me that these are 40 millimeters thick. Okay, so now I can start filleting, and the fillets are 40 millimeters. And we are done with the benches for now. So now I want to do the tabletop. So we want a plane. Now we can see bottom left, the top of the benches is 390 from the bottom, from the ground level, 390 millimeters. And the top of the table is at 750. Now what that tells me, subtract them and offset my plane, that should be fine. So I'll just say here, 750 minus 390. And that's where I'll design my tabletop. So my tabletop is a center rectangle, which is also 1700, but by 700 this time. and it's got a 130 millimeter circle in there, and I'll extrude that for another 40, and then I'm going to fillet it. Now, in speed modeling, I have come to the conclusion that this is a slightly faster way to fillet. So this is how I do it. You select the edges first, holding down Shift. Okay, and then you open the fillet, type the number. Oh, sorry, it'll be an 81 this time. Then hit Enter, and you're done. You just filleted everything. So this is the benches on the table done. And they're anchored because I didn't insert the part. I created a new part, and it was the first part of the assembly. So Alibre automatically anchors them, which is fine by me. That's how I want it. Okay, so now I'll go back into the assembly, and now I want to be doing the tubing, and that is the hard one, right? That's the difficult one. Okay, so how do I do that? Let's see, if all of the fillets in the tubes are the same, which they are, you can see that the fillets in the tubes, they are marked with a purple R50, and then in the bottom left it says R50 default tube bend inside radius, right? Inside. So all of the bends in the tubes are the same. So seeing that, I would just go for a 3D sketch. You know, honestly, I just go for a 3D sketch. But we need to pay attention here because now and I'll be sketching the center line, right? But what this means is that the center line for the bend is not 50 millimeters, right? It is 75 because 50 is the inside radius. So, okay, let's do some 3D sketching, and before I do that, I need a plane to start on. And let's see. So bottom left, we have 1350 between the legs inside the dimension. So that tells me that the center line is at 1400 millimeters. So I'll just make a plane here and offset it by 700. That's where I'm going to start my 3D sketch. Sorry guys. Now this would have cost me a lot of time. In a speed modeling situation, I need to start a new part first and then do all of that. Okay. So now I'll come in here and 3D sketch. And if you remember my video on 3D sketching, we always need to have the grid on. We always need to have the elevation window showing, which I will put here in the center for you. You might not be able to see it very well, but you know, if you want to follow along, you can look at your own elevation window. Okay, so I'll just draw a random line. I'm going to make one point coincident to the origin, and it's way back there. And then I want to make that line parallel to the x-axis. Okay, cool. Let me switch my plane so I can move this. Okay, now I can move it along this plane. By the way, the reason I created a plane, right, is because I want to start from here. Okay, so I was going the wrong way, right? So, and you need to switch planes to move things. Okay, so there we go. And now I can dimension this to be 700. Okay, that's cool. And then I'll click there, go straight up. So I need to dimension that now to be the difference between the bottom of the benches and the center line path of the tube. So we need to check our print again, right? And the bottom of the benches is at 350 millimeters from the ground. And the center line of that tube in the middle, right up there, is 685 plus 25, so that is 710. So what I'm going to say here is, I'll start the dimension and say 710 minus 350 And that's where I can now start sketching actual geometry lines, right? Let me put it to one side. Okay. Now I can start doing lines. So I'll click there. And you know what? I will hide my benches. Okay, I think this is easier. Okay. I don't want to be snapping to random stuff, right? So let's go there, and then to the top, and then I pick that up. And I'm doing this little circle and then picking that point, and you see that the elevation just snapped to the number that it should be. By the way, you know what? I'm not going to gimp myself. I'm just going to dimension all of this first. So I'm just going to dimension everything first, right? Because I want these straight lines to be in the correct location from the start. So now I'll be dimensioning this. This is half of the width of the center line. We already discussed why that's 500, so that's 250. Okay. And then these two are vertical. Yeah, they are. They already are vertical. So that is then a height of 685. Okay, you see it's starting to fall into place. If I look from this angle, it looks like it's making sense as well. Okay, so now I need to dimension this. Now what do I get? I get that that's 300 millimeters on the inside. So I'm going to add 25 on one side, 25 on the other. So that's a 350. And then I need to dimension this height. You know, I'm going up again. So now I'm getting a dimension from the ground, right, to underneath of the tube. Okay, so that's 325 again, exactly, right? Because the bottom of the tube is touching the ground, so that's below to below. So you just shift that. That's the correct one. Okay, so now what I'm going to do, now I'm going to just make a line here. Make sure that it's in a primary direction that's perpendicular to the other ones. And I will just say that this is, you know, D4. Okay. And now I'm going to fillet everything. And we said that we want a fillet of 75. So I'll just type that in, go in here and say apply, 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 and apply. Okay, so I'll close this off. While it is selected, I'll open up a plane. It'll snap it to the middle, because now when I sketch on this plane, I'm getting an origin which is at the point that the sketch I used is piercing that plane. Right, so this is a sort of poor man's piercing constraint. And I'll do a tube of 50 millimeters, right, and not do the inner diameter yet. So I'll just do that. Sweep, select this. So I've done a quarter. Now I'll mirror the entire part there. And now I'll mirror the entire part over there. So these are my tubes done. Now I'll bring the benches. I'll show the benches again, okay? And they're interfering like they're supposed to. So look what I'm going to do now. I'm going to do an assembly Boolean, okay? So which one is the blank? Well, the benches are the blank. And the tool, well, the tube is the tool, okay? And I'll check that I want to insert the results of that into the current assembly. So I'll insert that. This is the assembly Boolean. Now look at this. I will be suppressing the original benches, Okay, looks like nothing has changed, but now if I hide the cubes, my cuts are in there and they're perfect. So now I can calculate that this has a mass of 87 tons. Oh man. Now we need to go in here and and assign some materials. So the benches, the material I need to assign is ABS. Cool. And for the tubes, look, for the tubes, right? I need to assign the material that it is steel, and then I need to shell for 10 millimeters without removing any faces. So if I click OK, now let's see what really happened, right? So let's make a cut along the ZX plane. Flip it. There you go. It is now a tube, right? Because I shelled it, but I didn't remove any faces. So now it's a continuous tube, and you know, same here, right? Same deal here. So now I can actually check the mass, and the mass is 157.4, which, if I remember correctly, is the correct answer. Now the next part we'll be doing is these weight wheels, right? And I was blown away. This I wanted to do that so much, but unfortunately, Chris, we got to the final, knocked me out in the first round. Thanks for that, Chris. By the way, his YouTube channel is fully defined. Check him out. So what are these? These are weight wheels, right? And there are 3 of them, and you need to come in with the weight of all 3 of them. And there's a very handy note here on the bottom left that says these are the only dimensions that change. So it's the outer diameter and the thickness. So this inside fillet, this angle here, and the distance from the inner wheel all stay the same. So how would you go about drawing this? Well, we have this very, very handy section here. So, I mean, this is like telling us, look, start from there. So I will start an assembly, and this is this is the trick here, right? I'll start an assembly, and I'm going to call this TooTallToby World Championship Weight Wheels. So again, not inserting anything. I'll start a new part, call it weight wheel. Okay, and I'll start sketching here on the YZ plane, and I'm going to do this. I'll start a rectangle, make these 2 into reference. I'll just say this 3-point constraint midplane, and this distance is 25. Okay. Now I'm going to do, I'll start with a small one. Okay. So the small one has a diameter of 210, so I'll divide it by 2. Okay. And it also has a thickness of 18. Okay. Now I just need to do this. I want to say that these 2 are equal, and I also want to say, these 2 are equal, and this is a 45-degree angle. This is a depth of 4. Okay, and this is 18 millimeters. Okay. So I'll do the same on the bottom. And at this point, I just need to be making equal constraints, and I probably, and I'll just give a midpoint here. Okay, so I've got my profile now. I'll open up my hurl bar, and I'll just do a revolve around the y-axis. Okay, and now I need to take my cut. Okay, so it seems like the cut ends at this circle. why am I getting, well, I'm following the dimensions. So this is supposed to be right. Let's see, is that 75? No, that's not 75. What is 75? How is that 75? You have 25 plus 18 times 2. Oh, you don't have that. Ah, see? TooTallToby caught me there. Again. And again. So, look, guys. These are not equal. Right? So, let's see. Yeah. So these are 18 millimeters, but these are not. So I'll just give a vertical constraint there. And I'll say that this is, oh, come on. Yeah. I need this to be at a diameter of 75. Okay, so what did I miss here? Yes, another vertical. That's it. Okay. So if I do that again, that's 75. Okay, that tracks. Cool. Good to go. I think we're good to go. Now I'm going to just sketch here. I'm going to imprint this one, right? And line, tangent arc, line. Okay. So make everything symmetrical to the origin. Let's make these two vertical. And, I need to make this an R20. Is it? It is. And these need to be 60 degrees apart. Okay. And this needs to be 8 millimeters from here. So I want number 4. That's 8 millimeters. And now I need a center slot to cut this cut off. And I'm just going to cut through all circular pattern 5 times. Okay. So that's the smallest of the wheels done, right? So how would you go about making the other two really quickly? Well, you would make configurations. So that's config 1. That's config 2. If I was making actual parts, I would deselect all and say that these configurations only vary in terms of parameter values. In a speed modeling situation, I wouldn't bother. Make it active, right? And okay, go into the sketch and say that the 210, so this value now becomes this, and the 18 value now becomes 30. Okay, that's done. That's done wrong for some reason. Why is that? Well, I need this to continue being. So how did that? This needs to be 18. I must have messed up there for some reason. Okay. So that's config 2 done. And then you need a new one, config 3. You go in here again and you tell it that this now is 330 divided by 2. Ah, yes, I got the wrong 18. That's how I did that. Oh, which means, oh, I messed up. So let's go in here again. So this becomes 30, not this one. This becomes 30. And this becomes 2. Okay, so now this is correct. Okay, now let's go into config 3. You know, let's just go into the sketch. It seems like it's easier. And we'll make this 330 divided by 2, and we'll make this, what is that, 48. So now we have the 3 configurations, and we're going in here. I'll make 2 copies, and I'll say this copy is config 1. This copy is config 2. And this copy is config 3. Okay, and now I'll get the mass. Again, let's edit. These are all the steel parts. Okay, let's get the mass. And I checked, and 25.31 is correct. So that's how you would do that. So guys, 2 models from TooTallToby's World Championship finals, both assemblies, and you had configurations, you had assembly booleans, you have 3D sketching. TooTallToby was amazing this time. Best models for finals ever. Congrats, TooTallToby, and I hope you liked it. If you did, hit the like button, hit the subscribe button, and I hope I see you in the next one. Cheers, guys.